Hello, so today we're going to be talking about equivalent systems. So what you need to remember is that equivalent systems means that you're rewriting one or more equation that's in a system, often using multiplication or division property of equality. So I have a system right here, and I'm going to show you how to use the multiplication or division property of equality to rewrite it into its equivalent form. So there's no purpose to this at the moment. You're really going to have to rewrite with a purpose when we're talking about systems of elimination, or solving systems with elimination, rather. For right now, I'm just choosing numbers that I'm going to multiply by or divide by just to show you how to rewrite systems, okay? So if we take this first equation here on the left, I'm going to multiply the entire equation by 2. Okay, so it's kind of like an extended distributive property because I'm multiplying the entire equation by 2, meaning both the left and the right side, which is why we call it the multiplication property of equality, because whatever I do to the left, I must also do to the right. So when I use distributive property here, I'm going to multiply to everyone. So 2 times x is 2x, and 2 times y is 2y. And then also 2 times 4. A lot of students forget to multiply the last piece. And if you do forget, then that means you've only multiplied one side of the equation, and you need to multiply both. So in the example on the right, I'm actually going to divide by 3. Why? Just because I can, and I'm just trying to show you what division would look like here. So if I'm going to divide the entire equation by 3, each term on the left as well as the term on the right must be divided by 3. So negative 3x divided by 3 is negative x. Negative 6y divided by 3 is negative 2y. And then, of course, on the right side, 12 divided by 3 is 4. So using these two examples, let's do another step just to show you what that's like. So let's also multiply the left equation by negative 3. Okay, so when I multiply, again, I'm going to multiply to everyone to get negative 6x minus 6y equals negative 12. And on the right side, let's multiply this by 5. And 5 times negative x is negative 5x. 5 times negative 2y is negative 10y. And then 5 times 4 is 20. Okay? So that's just some examples of how you can multiply and divide equations to rewrite them in equivalent forms. So our original equation is equivalent to the one we multiplied by 2. And then this is also equivalent to the one we multiplied by 3. On the right side, this equation that we divided by 3 is equivalent to what we got as our answer, and then also when we multiplied it by 5. So these are all equivalent to each other, as well as these are equivalent to each other. So now let's take a look at what a Regents question would look like using this kind of method here. So we have a Regents question. Okay, if you would like to pause the video now so you can copy this down, please do so. I'm going to give you a second. Okay, so this Regents question says, a system of equations is given below. Which system of equations does not have the same solution? Right, because every time we multiply a system correctly, we will get an equivalent system. Now that means that I'm either going to multiply one, the top one, or the bottom one, or both, right? I can multiply them separately or together. And so the idea is that I rewrite them into equivalent forms, which means they will have the same solution. If I multiply or divide incorrectly, I'm going to wind up with a non-equivalent system and wind up with something that's not going to have the same solutions. So I like to investigate one equation at a time. So I take a look at the first, and they somehow got from x plus 2y equals 5 to 3x plus 6y equals 15. So I try to think, how did they get from here to 3x plus 6y equals 15? Well, it looks like they multiplied it by 3. So I'm going to check their math and see if they multiply correctly. So 3 times x is 3x, plus 3 times 2y is 6y, and 3 times 5 is 15. So it looks like they did it correctly. So this equation will have the same solution as our rewritten one. Then I take a look at the next one and compare, and they look like they're exactly the same, which means this is an equivalent system to our original, so they will have the same solutions. So these have the same solutions, okay? Now, be careful because that's not what we're looking for. We're looking for one that will not have the same solution. So let's take a look at number 2. So the same idea, how did they get from our first equation to this second one? Well, it looks like they tried to multiply by 4. Let's see if they did it correct. If I multiply, I'm going to wind up with 4x plus 8y equals 20, and that matches, which means they did it correctly. When I look at the second equation, again, these two match, so they are in fact equivalent. These will also have the same solution because it is an equivalent system. So if I take a look at the next example for number 3, our first equation matches, so obviously they are equivalent. So now we're trying to figure out how they got from 2x plus y equals 4, which is the second equation. How did they get to 6x plus 3y equals 12? Well, maybe they multiplied by 3. Let's check it out. 3 times 2x is 6x, 3 times y is 3y, and 3 times 4 equals 12. So these also match, which means these two sets of systems are equivalent, and they will have the same solution. Okay. So let's talk about this fourth example here. So obviously we found 3 that are equivalent, which means that the fourth one is the one that does not work. But let's just double check and make sure. So the first equations match, so they are obviously equivalent. In the second one, it looks like they tried to multiply by 2. So let's double check. So if I multiply by 2, I'm going to get 4x, so far so good. 2 times y is 2y. But then 2 times 4 is 8. They must have multiplied incorrectly here because this is what they should have done to make it equivalent, but this is the answer that they got. So this last equation does not match. So this choice 4 is the one that will not have the same solutions. Okay, I hope you enjoyed watching an A-Isaac creation, and I'll see you in the next video. Bye-bye.